Welcome back programmers in the 8th video of TensorFlow programming. In this video we are gonna talk about interactive session. This is the quick one. In the previous video we talked about what is session, how to use session, how to run session, what is the parameters session text. So in the today's video I'm gonna quick review of what is interactive session. In here you can see interactive session is nothing but it takes the eval method to run this session. In the previous video we saw how to run the common session, simple session run by sesh.run, but the interactive session run like this. Let's say sesh equal to tf.interactive session, I is capital in here, and whenever you want to execute the c, which is a plus b which is constant, the a value is 10.10 and the b value is 10.10 again, and c equal to a plus b. So whenever you want to run this c, execute this c, if I do like this, so I'm not gonna get the actual value, I'm gonna get the, that was warning. So you can see I'm gonna get the add 6 and 0, which is the TensorFlow name. So if I want to get the actual value of c, so I have to do like this, c.eval. The interactive session run with the eval function. So if I do like this, you can see I got the actual value of a plus b equal to 20.2. So that's how you can run the interactive session. This is not a big deal. So if you wanna run the actual run method using the sesh, so you can do it, sesh.run, and let's pass the c and run this. You can see we got the 20.2 again. Now what is interactive session? Interactive session, rather than to send an entire script to an interpreter, many Python developers prefer to write code interactively. In this mode, the interpreter displays feedback as each line is processed. Okay, so that's how you can run the interactive session. Okay, now let's move on to the main part of this video. But first, let's see what is logs. So log is nothing but TensorFlow provides the logging mechanism with many more messaging capabilities than regular print. There are 5 points to know about TensorFlow logging. You can read it, but we are gonna skip the log for now. If we need to use log, so we are gonna complete this log later, but log is not important, so I'm gonna skip all of the log. And now I am in the visualize data with TensorBoard. So I talked about how to use the TensorBoard, so if you wanna know, link is in the description. And this is the functions which we can use to make the visualization of graph. So the first one is scalar, create a summary operation that provide data about scalar. So the second one is histogram, create a summary operation that provide histogram data. And the third one and fourth one is important, audio and image, create a summary operation that provides data from an audio source and create a summary operation that provide data from an image. So I'm gonna skip all of this part because I already talked about TensorBoard, but you can try all of this function. This is not important, but you can try it. Okay, so we are gonna move in directly to the train. Chapter 5, training. Before the internet, old-timers like me entertained ourselves by actual speaking to one another. This is the author, not me. One rip-roaring game was 20 questions, in which one player think of an object and the other player asks question to determine what the object is. The question is allowed to ask at most 20 yes/no questions, and typical game goes something like this. Is this the larger than bread box? Yes. Can it move? Yes. It is animal? No. Does it move on wheels? No. Is it an evil robot? Matt again. That's it, you win. So in this chapter I am gonna explain you how the game 20 question is similar to the training methodology used in supervised machine learning. Training in TensorFlow. In the game 20 question, the questioner starts with a guess and refines his understanding with each answer. This game resembles the training methodology used in supervised machine learning. An application starts with general ideas or model of the desired system. The application compares its model to experimental data, determines the difference between them, and repeatedly refines the model to reduce the difference. The general training process is simple to understand, but implement training with TensorFlow isn't easy. The process involves 6 steps. So this is the very important step. You can write it down. Construct a mathematical expression for the general model. Declare variable to be updated in training is performed. Obtain an expression for the loss, which is the difference between the model and observation. Create an optimizer with the loss from step 3 and call its minimize method. And the fifth one is optional. Configure the sound argument of the session run method to feed batches of data to the session. Execute the session by calling the session run method. So the first one is construct a mathematical expression for the general model. So you have to create a general model and create the actual model to your data, and then declare variable and find the loss. Now what is loss? So let's say this is our model and this is our linear regression line. I'm going to talk more about what is linear regression, what is statistical regression in the second part of TensorFlow Dummies, when the end of chapter 1, the part 1. So this is our variables, and you can see this is some variable are far from the line, so distance between this line and these dots, so this is called loss. So you can see this blue line, this is called loss. So we have to find this loss and reduce this loss. So all of these dots are come in this line, in the center of this line, and that's called okay. So the basically our goal is to reduce this loss, okay, which is the difference between model and observation. Create a optimizer with the loss from step 3 and call it minimize method. So we are gonna see how we are gonna done this. Judging from question on stackoverflow.com, many developers have difficulty grasping how these steps are performed. In this chapter, explain this training process and then present example code that demonstrate how this step can be implemented in the TensorFlow application. This is the very important part of the machine learning, artificial intelligence, mathematician and TensorFlow. So formulating the model. If you know what is model, if you are from MSCIT or someone else, you know what is model, and without model we can't implement machine learning. Just as a game of 20 questions start with making a guess, machine learning start with the forming an initialized mathematical model of the system. A number of factors determine the nature of this model, including the system complexity, the structure of the input data, and the nature of the problem. Image data requires a different model than voice data. Classification problems requires a different types of model than prediction problems. This book focuses on two methods of mathematical modeling. The first involves approximating a set of data points with the shape. For example, if a system consists of two-dimensional points, you can predict future points by approximating the system with a two-dimensional lines. Lines are determined by the equation y equal to mx plus b. This is the very important equation, y equal to mx plus b. You can see in the previous video of linear regression, I talked about y equal to mx plus b in the detail, so you can check out that video. That video link is in the description. So this equation serves as the general model. The second method involves creating artificial neural network or ANNs. Through inspired by biological phenomena, every ANN represents a mathematical relationship. In chapter 7, introduce this exciting topic and explain how you can construct ANN in code. Okay, so this is the very important part. Whenever you model your system with a shape or a neural network, you need to refine the model until resembles the observed data as closely as possible. I talked about this too. We have to put that data as close as possible. Okay, you can see in here this dot is too far from this line, so we have to put these dots as closely as possible to this line. Okay, this refinement entail updating the model's parameter such as the m and b in y is equal to mx plus b. In a TensorFlow application, these trainable parameters are all instances of the variable class. Again, this refinement entails updating the model's parameters such as the m and b. This is the variable. Now you know what is variable and what is placeholder. What is the difference between variable and placeholder? If you don't, check out my previous video, link is in the description. When you are talking to customer, try not to use the terms guess and as in golly all of or guess is where way of base. The preferred term in initial estimate as in initial estimate proved inaccurate, but subsequent training runs will lead to better result. Okay, looking at variable. A first glance variable have a lot in common with the tensor. Both store data in multi-dimensional array and both can be processed with TensorFlow operation. But while a tensor can serve many purposes, most variables have only one purpose: to store data to be updated during training. A variable values will change as the training proceeds, and hopefully each change will be bring the model closer to the desired system. Variable have three other important characteristics. A variable maintains its value between successive execution of sessions. A variable must be specially initialized by an executing session. A variable is an instance of the variable class, not the tensor class. The last point is important. When working with variables, you need to call a new set of method and function. The following section explains how to create and initialize variable. So let's say variable 1 equal to tf dot capital V variable, and let's say variable value is 9.9. Now we can change the variable value whenever we want in the future, but we can't change the constant value. So let's say constant 1 equal to tf dot constant, and let's say its value is 9.9. Let's change the value into 5.5 so you can't confuse. Okay, variable value, we can change variable value whenever we want, but we can't change the constant value. Constant value is constant. Okay, so if I want to use this variable and if I want to print this variable, I have to use global variable initializer. So let's try ses equal to tf dot session. If I didn't use the global variable initializer, so I'm gonna get error like this. You can see print ses dot run, and if I print var1, you can see the error failed precondition error. So I want to create the global variable initializer. So let's say model equal to tf dot global variable initializer. Okay, and when I print the value, so first I have to run this model in this session. So let's run ses dot run. You don't have to print this model because this is only for variable. So you can see now we got 9.9 because we are using tf.global variable initializer. An application can create variable by calling tf.variable whose first parameter sets the variable initial value. You can see in here, you can even get in here I add the 9.9, but you can add list, you can add array, you can add the vector, you can add the any value you want. Okay, a variable's job is to hold data to be updated during the training. This is the very important part. You can write it down in your notebook. A variable's job is to hold data to be updated during training. Instead of initializing variable with constant value, many applications use random values. So you can use the random value too. I'm not gonna implement this program because I already talked about random values. TF.variable accepts boolean parameter called trainable. If you set this parameter to true, the variable can be updated by training. If you set it to false, the variable can't be updated by during. This is the very fucking important part. You can note it down too. Again, TF.variable accepts a boolean parameter called trainable. If you set parameter to true, the variable can be updated by training. If you set it false, the variable can't be updated by training. Initialize variables. One important difference between variable and tensor is that you need to execute special operation to initialize variables. That is, before you can train a variable, you need to create an initializer operation and execute it in a session. If an application attempts to an uninitialized variable, TensorFlow raises an error. If an application attempts to an uninitialized variable, TensorFlow raises an error. Attempting to use uninitialized or initialized value. TensorFlow provides three functions that create operations that initialize a variable. You can see the first one is variable initializer. The second one is local variable initializer, and the third one is global variable initializer. So the first one return an operation that initializes the variable in the given list. The second one return an operation that initializes all of the local variable, and the last one return an operation that initializes all global variable. This is the very important part. We just use the global variable initializer. You can see if I change this into the local variable initializer, you can see I got an error because this is not a local variable. And if I change this into the only variable initializer, let's try tf.variable initializer, you can see we still got error. Okay, so the error is missing one required positional argument. Okay, so the required positional argument is variable list. Application commonly calls global variable initializer because it creates an operation that initializes every global variable in the session. So we just did it. So we don't need these two variable initializer, we just need this. This is our main. Okay, so you can see this program in here. The author just used the with statement, but I used the single line session, so you can do it too. An application can check whether a variable has been initialized by calling is variable initialized with the variable name. So let's try this. Let's try to is variable initialized EYE equal to tf dot is variable initialized, and let's pass the variable 1 and let's print the IVI. You can see we got the tensor value. We have to run this in session, so let's print ses.run IVI. You can see true, we got true. Why we got true? Because we are initializing this variable globally. You can see in here, if I removed this and if I removed this statement and if I remove this statement too, now let's run the code. You can see I got false because now the global variable is commented out, so this variable is not initialized. You can check that the the variable is initialized or not by using is variable initialized function. Okay, so this is the end. This is the very important part of machine learning, artificial intelligence, or if you are using TensorFlow for maths, this is the very important part. From here I'm gonna talk about how to determine loss, how to minimizing loss with optimization, and we are gonna see some function that can help us to reduce the loss. So I'm gonna talk about this function too, y equal to mx plus b. So that is it for today's guys. Next part is very important. Hit on this subscribe button so you'll never miss my latest update. Hit on the bell icon too. Comment me for the next video. Share this video to other programmers or mathematicians. And you guys ready for the next video, because next video is gonna be very exciting. And in the next video I'm gonna talk about the very important part of machine learning, artificial intelligence, neural network, and so on. So that is it for today's guys. If you like this video, share this video, like this video, and subscribe to my YouTube channel. See you guys in the next video. Thank you.